Hello, I'm Manjola Zeneli. I'm come from Aleksander Moisiu University as an assistant lecturer, and I'm doing my research on Technical University of Sofia on digital twins in maritime industry. My presentation outline consists in the introduction, concepts of digital twin, the structure, life cycle of digital twin and some application, presentation of the software that are used to create virtual prototypes and 3D models, a case study for Durosport Authority, and conclusions. Digital twin in maritime. Digital twins enhance operational efficiency by creating virtual replicas of different operations and facilities in the port, like energy management, vessels, enabling real-time monitoring and predictive maintenance. They improve decision-making processing by providing data-driven insights, optimizing fuel and energy consumption, and reducing environmental impact. Additionally, digital twin facilitate training and simulation, allowing crew members to prepare scenarios for environments in the port. Digital twin solutions are related to traffic management optimization for vessels, vehicles, pedestrian movements, which enhance efficiency and reduces congestion. For cargo handling, improving logistical operations, and also for environmental monitoring, tracking emission data on energy, on carbon, and different, which reduce the levels that are high for the moment, and also increments the sustainability. Digital twin applications in maritime. To get a precise representation of physical system through digital twin, all relevant data must be integrated into unified architecture. So it's important to include collection of data. And the collection of data can be included in two manners, via the sensors or historically data. Then they are analytically elaborated and integrated with 3D model design. Digital twin, from the aspect of business case, can be shown as a Venn diagram, and three pillars of digital twins are analytics, 3D models, and data. This is an example of an inventory system with the digital twin. The first is requirement and gathering data. The gathering data is done by the PDA devices, which take the barcode of each asset that is in the port. Data acquisition is from sensors, from historical data in the past, and also real data from the sensors. And integration is good to be from various types of data in order to ensure consistency and good presentation for the data. The next step is modeling and simulation. Modeling and simulation can be done via mathematical models, algorithms that simulate the behavior of the performance of the assets, and predictive analytics capabilities to forecast asset performance and identify potential failures. Then we have development and implementation, and optimization and improvement. This brings more efficient forecast for next year purchases and updated asset information. Then final step is retirement or replacement, which creates an overview of the asset in the port. Software that are used for creating digital virtual prototypes or digital twin are geographic information systems, virtual augmented and extended reality, and one example is Adobe Aero application, Microsoft Azure IoT and digital twin, databases like SQL Server, and generative pre-trained transformers GPTs. Digital twin design process is from physical asset sensor and actuators to data acquisition, digital twin modeling and simulation, analytics, decision support, predictive maintenance and optimization, and visualization and user interface, dashboards, reports, and animation 3D. This is 3D from different areas of the Durosport, which we have used for creating the full view of the digital twin. We have taken the data for energy for 1 year from different buildings on the port, and these are the energy consumption for different months in different buildings in the port, as can be seen in the figure. This is a map of the port. These are 3 buildings for which we have constructing the digital prototypes. This is a view of Microsoft Azure. Here is created a relationship between the Duros port environment, the buildings, and the sub-buildings. This was mandatory due to the language that used Microsoft Azure Digital Twin is called DTTL, and the basis of it was JSON language. Here is the graph preview, the Duros port environment, all the buildings and the sub-buildings, name each, a different view of the twin graph. If we click in each one of these, we see the energy that is consumed for 1 year of the different buildings or sub-building, if we know. Here are the views. In this, we have shown the energy consumption. In this view, we have shown the name of the building that we are searching information for. Also, we have a view of the 3D model of the port, the real view of the port, 3D model and twin graph, and 3D model and model graph that are extracted from Microsoft Azure Digital Twin platform. Duros port, the application of digital twin in the port brings some benefits, which improve energy efficiency rates, foster green transformation goals, education the staff of the port on managing and saving energy in a moderated manner. Conclusion, all things considered, data-driven decision-making, optimization, innovation over the whole life cycle of maritime assets and operations are made possible by digital twin, which have the potential to completely change the maritime sector. Digital twin adoption has the potential to increase human-computer interaction by making them more comfortable and fearless for an expected future, significantly improve maritime operation and efficiency, sustainability, competitiveness, and sector imbalances. Many studies show the potential and development of digital twin in ports. Thank you for your attention.
Manjola, so the first question is, which of the technologies you mentioned, GIS, etc., were used in the port case study, and how were the separate elements integrated?
We have used Microsoft Azure Digital Twin and Microsoft Azure IoT in the models that we have created. And how were the separate elements integrated? There are the first element is integrated with AR, which are the graphics and the 3D models, and the second elements are created with some mix of the pictures with Canva, where are created the views extracted from Microsoft Azure Digital Twin and the 3D models.